Our next guest is Constant. So Mrs. Constance Moretti. He has a PhD in engineering in smart textiles. She made her PhD in Gemtext laboratory in Roubaix in France on electrochromic color changing textiles, and now has a patent technology. She is currently manager on the textile department of Brochier Technologies, a French innovative company developing optical fibers-based woven textiles, and take care of several projects regarding their application for automotive, building, safety, and fashion tech. So, Constant.
Thank you very much for the kind introduction.
Thank you.
And thank you for all the team of Context for inviting Brochier Technology today. I'm so happy to be here and to have some fabulous new ideas and new trends in smart textiles. I think it was during my master's degrees in the north of France and then during my PhD that I started to realize that it is really a nice period to work in textiles today. And I think it's an idea we are many to share today, that so many things are happening today in the textile industry. And I was lucky enough to continue in this certitude because I now work in a French company called Brochier Technology, which is weaving optical fibers to develop innovative textiles. So my topic today will be to try to explain you how from one innovative idea we are making a commercial success. So our main technology is called the LITEX, so the luminous optical fiber-based textile. And in some main steps, the name of Brochier is quite well known in the south of France. We are around Lyon, because the family of Brochier was a huge family in silk weaving, so in traditional textiles. And then they had to evolve and to develop technologic textiles. It was glass weaving, and in the 60s it was the nose of the Concorde plane which was woven with these innovative textiles. And then in year 2000, the first optical fiber-based luminous dress was developed for a fashion show. And here we are today with a dedicated companies and two other linked companies and many applications and commercial success. And so the question is, how did we pass from that only wedding dress to so many projects and so many applications today? So the LITEX, which is a patented technology, is based on optical fibers, polymer optical fibers, woven using the traditional jacquard weaving technique adapted to this innovative fiber with other technical or traditional yarns to create patterns or to create logos or to create functional textiles. I have here some examples and some others, so if you are interested, feel free to come back up, and here some examples. So just a few words about how the technology works. We are weaving the optical fibers, and then we are treating it to make it able to emit the light, and we are connecting it to an optical system, generally LED. So the optical fiber itself is not emitting light, it is diffusing the light of the LED. I assume that a lot of you here are familiar with this process. So the light is diffused in the core, and we come to degrade the cladding to let the light go out of the optical fiber. It has many advantages because we keep textile abilities, textile flexibility, textile conformability. You can assemble it with other materials, make composites, or glue it or stitch it. And you have, of course, no heat on the textile itself. Everything is in the electronic material, so it is perfectly adaptable for skin contact, for example. And so now the main topic of today, how did we develop a successful company based on this innovative product? So we are back in 2000. A French stylist, which is named Olivier Lapidus, comes to the now president of Brochier Technology and told him, for my next fashion show, I want light in my dress. So Brochier Soierie at the time was a company which was weaving silk, and they tried to make something with light. It was optical fiber that were woven to make this dress. It had a nice success, gave a nice visibility to the company, and kind of had a wow effect. Still today you can find things about this dress on the internet. And then the idea was, okay, either it was a one shot and it's over and we go back to silk weaving or to glass fiber weaving, or we try to capitalize on this innovation. And it was the choice that was made. And from this step, we tried to develop a technological product for commercial application. Of course, it wasn't the same textile that was used for the wedding dress. We had to adapt it. We had to learn about international standards for many range of application. We had to develop new technological solutions, and so on. We made our way to technical applications of this particular textile structure. Then in 2007, we had enough success to make a full company, because before it was a department in the Brochier Soierie classical weaving structure. From now on, we were able to make some collaborative projects. And I know it is the main idea here for some of us, to be able to meet each other's interest and to have some new projects in common, to use each of us knowledge and know-how to develop new things. It's a thing we can do also here in Brochier Technology, and we've made a lot of national projects and now a few European projects to develop innovation, which, as always, in the main idea, has to be adapted to the market. In all our history, we continued to make some wow effect projects, as we may call them. Not always wedding dresses, because you know fashion, you make one wedding luminous dress, then everybody else doesn't want a luminous dress. But we made a nice project recently with a shoe developed for the French sneakers mark called Eram, which is luminous. And we've made some art projects and some architecture projects just to make sure we are still visible. But in the same time, we continue to develop technical applications. So in 2014, a daughter company called NeoMedLight, which is a spin-off, was created. NeoMedLight is dedicated to medical application of this technology, because some diseases can be treated with light. We did not invent it. We just brought textile flexibility to an existing solution. Then in 2015, another company was created. Its name is EFI Lighting, and the application of EFI are only for automotive application. So either inside or outside, for design or for safety. And so here we are today, a company with multiple applications. So for transport, art, communication, of course, always innovation, health, architecture, safety, transportation, many applications, some of them with commercialized success, some of them still in development, but in so many possibilities. To spot a little bit on commercial success, I will talk a little bit more about EFI Lighting. So here you have some example of development. Is a woven textile structure which is bringing, for example, a welcome signal when you enter your car, or which can blink to signal you some danger outside of the car. We also had some nice development in the railway industry. For example, here outside of a train. And other nice commercial applications are, of course, the medical treatment. Here you can see what is called the Billy cocoon, It is a product that is sold internationally. About 1 year ago, they had the FDA approval, so it is now sold in the USA. The principle is to use blue light brought by a special LED into the textile to treat neonatal jaundice. So for babies, sometimes who has a disease called jaundice, you can treat it with this, but thanks to the latex textile, with comfort and with the ability for the baby to be carried in parent's arm instead of being put in a box outside a blue light. And we are also working for other applications such as skin cancer disease and so on. Of course, still a few wow effect projects, which I cannot resist to show you. Some in advertising. Here the fashion tech, you can see the sneakers, which are luminous. In architecture, here the latex is complexed with a colored glass. For special event, in Lyon we have a nice event in the winter, something about light outside of it's called the Fête des Lumières, in all the city with light and with sound. And of course, sometimes we make some event. Here it was with a famous French lab, CNRS, and around photocatalysis. And with art, we are lucky enough for the French artist Daniel Buren to trust us since a few years. So here's latex. And we still work on ongoing development solution. We talked a lot today about photocatalysis. It is also something that can be done with the latex. So, as you may know, photocatalysis requires the association of light and of chemicals. Generally, the light comes from outside. Thanks to our solution, you can apply the chemicals directly on the luminous fabric, so you have a maximum photocatalytic effect. It is something that is already working in air or in water, not commercialized yet, but we're working on it. And also with some interest about vertical farms to grow plants or to grow specific algae, you can use the light brought by the latex to increase the production instead of having everything horizontally. And still many innovation projects with flexible displays. Here everything is independent with a flexible textile-based display with sensors and so on. So thank you for your attention. I hope this might have inspired you. I will still be here tonight for the networking session. If you have any ideas or any if you want any other demonstration, you can find us on the social network. We are Brochier Tech and some information with the hashtag latex inside. Thank you very much.